Hey everybody, this is Larry. This is day 15 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about 958, check completeness of a binary tree. Apparently I haven't done this problem, so I'm excited. Yeah, let's get into it. Hope everyone's having a great week so far. It's just been nuts here in New York. It's snowing a lot, and I just came from outside. It's cold. Everything is in my face. I don't know. My eyes are tired. Anyway, let's go. So, given a root of a binary tree, determine if it is a complete binary tree. In a complete binary tree, every level except for possibly the last is completely filled, and all the nodes in the last level are as far left as possible. It can have between 1 and 2 H nodes inclusive in the last level H. Okay. Oh yeah, so it has to be as far as possible. Yeah, I mean, let me think, right? There are a couple of ways you can do this. You have to look at every node in the tree-ish to kind of get into it. Though there's only 100 nodes, so you can be a little bit lazy and sloppy, but you should be able to do this in linear time. And the way that I'm going to do it is, yeah, I mean, I think there are a couple of ways you can do it, and I don't know that this is the canonical way of doing it, but, and especially since, to be honest, it probably doesn't work with a big enough, it probably doesn't work with a big enough number of nodes, because it doesn't do it that way. But I think the way that I'm going to do it is, the way that I'm going to do it is just numbering the tree and then see if there's any numbers missing, is what I was going to say. I think this is definitely not the way that they recommend, but wait. What are the values? That's what I'm going to see. I'm just right now. I'm just double checking that the values, do they have to line up, or they just happen to line up, or do the values have to be just anything, right? And it's just, I don't know why they have it then, but okay, fine. So yeah, so then maybe get max. Node. If node is none, we return. Otherwise, well, maybe something like this, right? Otherwise, get max node dot left, which is current times 2 plus. So we have 0, 1, 2. So 0 times 2 plus 1, right? I think my numbering is different from their numbering, which is why this looks a little bit weird. Right? And then just return get max of this, right? Or this is a little bit off actually, because then now I think this is divided by 2 to get the previous one. Maybe that's a little bit better, or maybe this should just return 0, and then it does this, and then it also returns the current value. Yeah, and then maybe that's better actually. And then basically now you have, max is equal to get max of root 0, right? Oops, what did I do? And then I'm just trying to think whether I could do this without storing every number, right? Because obviously that would be easy, but let's try it the other way. So find gap maybe, right? And this is going to be the same. Oops. So yeah, if this is none, then and then we just return true. Or false in that there's no gap, maybe. And then otherwise we want to, if current, so that means that the current node is none. Oh yeah, well, if current is less than mx, then we return true. Otherwise we return false, and then yeah, that's it. And then return find gap, node dot left, current times 2 plus 1, and node dot right, and find gap node dot right, current times 2 plus 2. This is a very janky way of doing it, but you know, we'll see if this works. I don't think I recommend this way at all, but I just wanted to try something new. So yeah. So this return false. Why? Tell me why. Oh, my conditional is weird. So it's either this or this. Yeah. Okay, now it's just even more wrong. Doesn't put anything at all. It is missing 5, which is true. The numbers don't really match, but oh, I think I'm doing this. Okay, yeah, because we want to, because this returns whether it has a gap, so we want to not it. I don't know, logical things. Let's give it a quick submit. Hopefully I didn't have any silly mistakes, and I don't. Yay. We did do this in a funky way. I don't know, like I said, I don't recommend it. I think you probably should just like do some other logic. But like I said, I wanted to try something funky, something new. So let me know what you think. Let me know how you did this problem. And yeah, what is the complexity, right? So it's going to be linear time, linear space, or O of H space. Usually it's O of H space because, you know, the stack the stack size is going to be O of H. But in this case, it is also O of H because this is going to multiply by 2. So it's going to take 1 bit per H for height, right? So this means that this is going to actually get even bigger. So yeah, that's basically the idea. And depending on how you want to count it, this actually could be H squared. So maybe that's actually really bad, to be honest. But it's just that it is less than 100. So that's why we get away with it. Because on a stack space, every size on the stack is going to be O of H size on the stack. So actually it's going to be O of H square space, the way that I did it. But I wanted to try something funky. So I don't know. Let me know what you think. But yeah, let me know what you think. And that's all I have with this one. I am going to do the weekly premium one next, just because, well, why not? So definitely hit all the buttons, hit the button, like button, hit the subscribe button, join me on Discord. And also, yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.